Hello students, welcome to the new lecture of the Engineering Chemistry course. Before starting the today's lecture, just have a quick recap of the previous class. In the last class, we have completed the unit 4 and the topic lubricant. In the previous class, we have discussed in detail about the viscosity and viscosity index and emulsification. So, by finishing this topic, we have completed the unit 4, which included the topics cement, glass and the lubricants. So let us begin with the new unit 5, organic reaction mechanisms and the introduction of drugs. So in today's class, we are starting with the unit 5, organic reaction mechanism and introduction of drugs. The unit 5 includes the following topics. Basically, the organic reaction mechanism and the drugs. The reaction mechanism includes addition, that means addition reactions, electrophilic and free radical addition reaction in alkenes, nucleophilic addition reactions in aldehyde and ketones. In the substitution reaction, we will discuss the mainly the SN1, SN2 reactions in the nucleophilic substitution reaction category, and electrophilic aromatic substitution reaction in benzene in the electrophilic substitution reactions. And we will also discuss about the free radical halogenation of the alkenes in the category of the free radical substitution reactions. Then the third class of the organic reaction mechanism is the elimination reactions. In the elimination reaction, we will discuss in detail about the elimination in alkyl halides and dehydration of the alcohols. We will also discuss in detail about the rearrangement reactions, which includes carbocation and free radical rearrangements. These all topics will be covered in the organic reaction mechanisms. In the drugs, we will discuss about the introduction, synthesis, properties and uses of aspirin and the paracetamol. So these are the topics which will be covered in the unit 5. To discuss all these topics in detail, or if you want to further reference readings, so these are some suggested readings: Organic Reaction Mechanism by Jerry Marsh and Reaction Mechanism by the Solomon. These are two standard books which you may refer for your further reading. You may also have the access of the online libraries like National Digital Library and the Pearson e-Library. Now, let us begin with what is organic reaction mechanism. Before going to the reaction mechanism, we must know what are the organic reactions. So, the organic reactions are the reaction which involves the organic compounds. What is the organic compound? Organic compound is the compounds which contains the carbon atoms. So, the reactions which involves the organic compounds are known as the organic reactions. Now, second main important thing is the mechanism of these reaction is the organic reaction mechanism. So, how we define the reaction mechanism? Basically, a reaction mechanism is the step-by-step sequence of elementary reactions by which overall chemical changes occurs. That means by which the final product formation taking place. So, the organic reaction mechanism is the study of step-by-step sequence of elementary reactions of organic compounds. Okay, so this is the organic reaction mechanism. I hope it is clear to all of you now what it means, the organic reaction mechanism. Now, coming towards the elementary organic reaction. Basically, the organic reaction begins with the attacking species onto the organic molecule. Okay, so when this attacking species attacks onto the organic molecule, This results in the formation of the various kinds of intermediates. So, due to the attack of this attacking species onto the organic molecule, various kinds of intermediates are formed, which leads to the formation of the final product of the reaction, and sometimes the byproducts of the reaction are also formed. So, basically, the organic reaction involves four important type of compounds. First is the attacking species, which is also known as the reagent. Second is the organic molecule on which the attack takes place, which is known as the substrate. Third one is the intermediates formed during the reactions, and fourth important is the final product of the reaction formed. So, you must remember the components necessary to study the reaction mechanism of an organic reactions. The important components for the organic reaction mechanisms are the reagent, the substrate, the intermediate, and the final product. So when the attacking species or a reagent attacks on the substrate, that is the organic molecule, this leads to the formation of various kind of intermediates, and ultimately these intermediates are converted into the final products, and sometimes some byproducts are also formed. So this is the simple elementary reaction. Suppose this is the organic reaction. So R is the organic molecule, that means substrate here. X is the attacking species, that means reagent. P is the final product, and Y may be the byproduct of the reaction. So these are the important compounds which we must know before study the organic reaction mechanism. Okay. So first let us look on the reagent or the attacking species in the organic reactions. Basically, these attacking reagents are the chemicals that we add to bring about a specific change to the organic molecule. Okay, so these attacking species are used to attack on the substrate molecule to bring the specific desired change in the molecule. Any general reaction in organic chemistry can be simply written as this type, that means reagent plus substrate giving the product. This is the simple organic reaction. When reagent attacks on the substrate molecule, result in the formation of the product. Okay, based on the ability of electron donating or electron withdrawing capacity, the reagents or the attacking species is of two types: electrophiles and the nucleophiles. So basically the R reagent attacks on the substrate molecule to gives the final product. Now this are based upon the electron donating or electron withdrawing power or electron withdrawing ability. These reagents are of two types: electrophiles and the nucleophiles. Basically, the electrophiles are the electron deficient species, and these behave as a Lewis acid. Since these are the electron deficient species, that means these are electron acceptors. That means these are having the capacity to withdraw the electrons from the substrate. Second one is the nucleophiles. So nucleophiles are the electron rich species and behave as the Lewis bases. So since these are the electron rich species, so these nucleophiles are having the tendency to donate the electrons to the substrate molecule. So let us have a detailed look on the electrophiles and the nucleophiles. Electrophiles. The electrophiles are the electron deficient species. Okay, so these behaving as the Lewis acid. These species are having the tendency to extract the electron from the substrate molecule, since these are the electron deficient compounds. For example, all the non-metal cations and the metal cations which have the vacant d orbitals. For example, Cl plus, NO2 plus, CH3O plus. These atoms are behaving, atoms or the group of atoms are behave as the electron deficient species, hence these all are the electrophiles. Similarly, some compounds are having the incomplete octet. For example, boron trifluoride, anhydrous zinc chloride and anhydrous FeCl3, anhydrous aluminum chloride, carbene. These are the compounds which are also act as the electron deficient species. And some other non-metal oxide gases with the incomplete octet are the carbon dioxide, sulfur dioxide, etc. So these all compounds are the electron deficient compounds. So we may classify the electrophiles in two categories mainly. First is the category in which the atom or the group of atom possesses the positive charge. Since these are having the positive charge, therefore these are the electron deficient species and having the tendency to extract the electron from the substrate. Secondly, these are the neutral species, not the positively charged species, but these are electron deficient due to their incomplete octet. For example, BF3, ZnCl2, FeCl3, AlCl3 and the carbene. So these all are the compounds which are the electron deficient species. So any kind of positive ion cations always behave as the electron deficient species. Similarly, the compounds having the incomplete octet also behave as the electron deficient species. That means these are the electrophile reagents. Now, second type of reagents are the nucleophiles. These are the electron-rich species and behave as the Lewis bases. These attack on the electron deficient area. Since these are the electron-rich species, so these attack on the electron deficient area. That means due to their electron richness, these can donate their electron to the substrate molecule. Okay, so the nucleophile may be classified in two categories. First is with the negative charge, second is the neutral molecule. The negative charge containing species, for example, H minus, CH3 minus, Cl minus. All the negatively charged species are the electron rich species, that is why can behave as the nucleophile. Some neutral molecules which are having the lone pair of electrons can also act as the nucleophile. For example, water, ammonia, methyl alcohol. These possesses the lone pair of electron on oxygen, nitrogen and the oxygen respectively. So these can also behave as the nucleophile. So now you can understand what are the electrophile and what are the nucleophile. Basically, the electrophile are the electron deficient compound, may be positive ion or may be the neutral atoms. Since these are the electron deficient compounds, so they attack on the electron rich substrate. While the nucleophiles are the electron rich species, it may be anions or it may be the neutral molecules. Since these are the electron rich species, so these can attack on the electron deficient substrate. Now, second important term during discussion of the organic reaction mechanism is the cleavage of bond. That means breaking of bond. Suppose there is the bond between the A and B atoms to form the AB molecule. So this bond is formed by the sharing of two electrons, one from A and second electron from the B. This is the covalent bond. So the cleavage of bond may be of two types. First is the heterolytic cleavage and second is the homolytic cleavage. Heterolytic cleavage is the unsymmetrical bond breaking. That means when the bond cleavage taking place, both the shared electron goes to the one atom. If it goes to the B atom here, so B possesses now the negative charge and A possesses the positive charge. So always the heterolytic cleavage results in the formation of the ions, cations as well as the anions. Remember, it is the unsymmetrical bond cleavage. Why it is the unsymmetrical bond cleavage? Because in this type of bond cleavage, the electrons of the bond goes with the single atom only. So the electron if goes with the B atom, so B will be having the negative charge. If electron goes, both the electron goes to the A atom, then A will possesses the negative charge. So in this type of cleavage, electrons of the bond will goes to either of the atom, either with the A atom or with the B atom. So this results in the formation of the cation and the anion. The positively charged ion is called the carbocation, while the negatively charged organic ion is called the carbanion. So always remember, the heterolytic cleavage of the organic compound results in the formation of the carbocations or the carbanions. Okay. Now, second type of bond cleavage is the homolytic bond cleavage. This is the symmetrical bond breaking. What it means? Symmetrical bond breaking means the electrons of the bond, this bond is formed by sharing of these two electrons. So electrons of the bond goes with both the electron, a single atom with one atom and second single electron with the second atom. So this is shown by this half arrow. This is not the complete arrow, and movement of both these electrons shown by the full arrow. So this half arrow means one electron shifted with the B atom. This half arrow results, that means this electron moves with the A atom. So always this symmetrical bond breaking is the homolytic cleavage, which results in the formation of the free radicals. A possesses single electron, B possesses single electron. So this results in the formation of the free radicals. So always remember, in the organic reaction, if heterolytic cleavage taking place, this results in the formation of the carbocation or the carbanion. While in the homolytic cleavage, always formation of the free radical takes place. Now, coming towards the types of organic reactions. The important types of organic reactions are addition reaction, substitution reaction, elimination reaction, and the rearrangement reaction. What is the addition reaction? The reactions which involves combination between two reacting molecules to give a single molecule of the product. That means in this type of organic reaction, the substrate molecule combined with the attacking species to give the final product. So this is the combination of the substrate with the reagent. Okay, for example, and since these in this type of reaction, the attacking species or the reagent add on to the substrate molecule. So the substrate molecule, that means organic molecule, must have the double bond or the triple bond, must have the unsaturation. Why? Because only due to the unsaturation the attack is possible or the addition is possible. So this is the simplest example of the addition reaction, in which addition of HBr taking place on the ethylene molecule. The ethylene molecule having the double bond between the carbon and carbon, this HBr attacks on this double bond, and finally formation of the bromoethane taking place. Second type of reaction is the substitution reaction. A substitution reaction is that which involves the direct replacement of an atom or a group of atoms in an organic molecule by another atom or group of atoms without any change in the remaining part of the molecule. For example, when attack of chlorine taking place on the methane in presence of sunlight. So what attack it results? This chlorine replaces the hydrogen. So in place of this hydrogen in the product there is the chloride, and finally HCl is eliminated. Remaining molecule, that means this molecule is untouched. This remain in the product as it is. Only the change, the hydrogen is replaced by the chloride. So this is the example of the substitution reaction. Now, third type of reaction is the elimination reactions. An elimination reaction is one that involves the loss of two atoms or the group of atoms from the same or the adjacent carbon atoms of a substrate, leading to the formation of the multiple bond. Means when a substrate molecule is attacked in presence of acid or base or in presence of catalyst, so there is the elimination of some atoms or the group from the substrate molecule. So this is the just reverse reaction of the addition reaction. Suppose this elimination taking place from the adjacent carbon atom, so H and OH removes, results into the formation of H2O, and finally ethylene molecule is formed. So this type of reactions in which atoms or group of atoms are eliminated from the parent molecule. Now next is the rearrangement reactions. The reactions involving the migration of an atom or group of atoms from one atom to another within the same molecule are called the rearrangement reactions. That means within the same molecule some atoms or group of atoms are rearranged. That means shifted their places within the molecule itself. For example, 1-butene, it is the example of 1-butene in presence of acid catalyst. This 1-butene, that means this methyl goes here, CH2 goes here, converted into methyl, and this results into the formation of the 2-butene. So this is the example of the rearrangement reaction. So basically rearrangement reactions are those in which migration of atoms or groups within the molecule taking place to form the stable product. Now time for the learning check. Read the question on your screen and think for its answer. Which of the following is not a nucleophile? Cyanide, BF3, RNH2 or OH minus? Think for that. We will discuss its answer in our live class tomorrow. Second question for the learning check. Which type of following reaction it is? This reaction is which type of reaction? Addition, elimination, substitution or the rearrangement reaction? Identify the type of reaction. Both of these questions we will discuss in our tomorrow's live class in detail. Till then, just a quick revision of the today's topics covered. Today we have started with the Unit 5 Organic Reaction Mechanism and the Introduction of Drugs. Started with the introduction of the organic reaction mechanism. Any reaction which involves the organic compound are termed as the organic reaction, and the step-by-step methodology of organic reaction is known as the organic reaction mechanism. In any kind of organic reaction, three things are very important. One is the reagent, second is the substrate, third is the intermediate, and fourth is the product. So reagents attacks on the substrate molecule. This is the organic molecule. So first important term is the reagent. On the basis of the electron donating or electron accepting tendencies, the reagents are of two types, electrophiles and the nucleophiles. Then we have discussed about the types of bond cleavage, in which we have discussed the two types of bond cleavage, homolytic and the heterolytic bond cleavage. Homolytic cleavage always results in the formation of the free radicals, while heterolytic cleavage results in the formation of the carbocation and the anions. Then we have just discussed about the types of organic reactions. Brief introduction of types of organic reactions we have discussed, in which addition, substitution, elimination and rearrangement reactions we have discussed. So that's all for the today's class. Thank you. Take good care yourself and keep enjoy e-learning at home. Thank you.